Okay, so now we will continue to the last part of normal distribution. So you have normal approximation to binomial or Poisson, meaning you are going to basically change a binomial distribution into normal or a Poisson distribution into normal. All right, so the learning outcomes for today will be to recognize, first of all, you need to recognize the original question. Is it binomial or is it Poisson? The second thing you need to do is define the probability as per the original distribution. So if it's binomial, you define the whole thing with n and p. If it's Poisson, you define it with the lambda. Okay, then you need to know when can you change it to normal. Okay, then we will follow the steps. I will go through these 4 steps and I would expect you to follow the 4 steps as well. This will be the easiest way. If you just follow the way we learn in this video, you won't go wrong. These questions, students always go wrong. It is about 10 marks in your final exams. Okay, so let's look at the conditions when you want to change. Okay, so we'll go on with binomial first. So originally, if it's binomial, when can you change it to normal? Okay, when your n is large, when your n is more equals to 20, and when your p is small, smaller than 0.5. All right. And if the number of probability is greater than 9, meaning you have to calculate 9 or more probabilities. So you need to meet all the conditions. Your n must be bigger or equals to 20, your p must be smaller than 0.5, and you have 9 or more probabilities to greater than 9 to calculate. Greater than 9 meaning is 10, 11, 12, 13, 14. Why this one you can use normal? Because x, if it's more equals to 10 probability, means is basically you have more than 10 to more than 9 to calculate. Okay, then you will change it to normal. How to change to normal? So originally, if it's a binomial distribution question, you have n and p, correct or not? We have been doing this. So when you change it to normal, there will be an asterisk sign there. Why is there an asterisk sign? There is an asterisk sign because the reason that you have the asterisk sign is because you are changing it to a different distribution. You are changing it to normal. So now if you're changing it to normal, you can only do it when it meets these rules, which we will go through in an example later. So basically, what do you need for normal distribution? You need mean, you need standard deviation, right? So what is your mean? NP. We already learned that. So n times p, the expected value. Then you need your standard deviation, which is the square root of NPQ, and you will define it in your normal distribution. Whereas for Poisson, when do you change it to normal? When your lambda is large. When your lambda is n is more equals to 10, you can change. And so Poisson distribution is easy to remember. And when you have more than 9 probabilities to calculate, usually it's very obvious. They'll tell you what's the probability there are more than 25 of them. Then you know you cannot use binomial or Poisson to count one by one, right? Then you will change it to normal. So when you change it to normal, same thing, you write original distribution first. Then when you change, you have a little asterisk there. Why is there an asterisk there? Because this is new distribution now. All right. Then you will have n with the mean and standard deviation. Your mean is your lambda. We have just done this in the extra questions. And your standard deviation is the square root of lambda. Okay. After you have already known what is the rules and when you can change it, there is a second thing that you need to do called continuity correction. You only do this correction when you change from binomial to normal or you change from Poisson to normal. Why do we do that? Why do we do this correction? Because binomial and Poisson was discrete distribution. You are changing discrete to continuous. That's why you have an extra step called continuity correction. Okay, continuity correction is not so difficult. Okay, so now let's say originally if it's discrete, x is lesser or equal to 3. Whenever it is lesser or equal to, you will add 0.5. So do you see in a normal distribution there will be a star, x star lesser or equals to 3.5. Now when it's x is less than 3, okay, so if it's originally, don't confuse yourself. If it's normal, you straight away change to less or equal to 3. But this is originally discrete, meaning it might have been binomial or might have been Poisson. So if I'm saying less than 3 when it comes to binomial or Poisson, what am I talking about? Less or equal to 2. So less or equal to 2, you will have x with a asterisk, lesser or equal to, you add 0.5. Can you see that? Lesser or equal to, add 0.5, more equal to, minus 0.5. When it's exactly, you don't need to do anything. Okay, you can use the discrete distribution as per usual. Nothing is different really. No need to do any correction. Okay, when you have x more equals to 5, x lesser equals to 8. So you need to change more equal to minus, right? See, more equal to you minus 0.5, lesser equal to you plus 0.5. That's why it becomes 4.5 to 8.5. Okay, now when you have something like this, x is more than 5 but lesser than 8, less or equal to 8. So if you have a discrete distribution, either binomial or Poisson, what are we talking about? If x is more than 5, we're talking about 6, 7, 8. You understand? Then only you do the continuity correction. Alright, so continuity correction, same thing, more equal to you minus 0.5, less or equal to you plus 0.5. Same thing here, x is more equals to 5, so that means you know if it's a discrete distribution is 5, 6, but you stop at 7 because x is less than 8. Then you do the continuity correction. X is more equals to 4. I told you what? More equals to minus 0.5. X is more than 4. If it's a discrete distribution, if I'm saying more than 4, 5, 6, 7 and above, right? Then you minus 0.5. So don't confuse yourself, all right? If it's originally discrete, then you will do this continuity correction when you need to change it to normal, all right? So let's practice this continuity correction here. If I'm saying at least 6, so x should be more equals to 6, more equals to I minus 0.5. Not more than 7, less or equals to 7. So less or equals to plus 0.5. 3, and this is just example, this is example. I want to show you how to do continuity correction. But when you have only 3 probability to calculate, usually you will use the discrete distribution, okay? Probability of x less or equals to 3, less or equal to at 0.5. More than 120. If I'm saying more than 120, what am I saying? 1 to 1 and above. So more equals to 1 to 1. Then you do your correction. More equals to you minus 0.5. Can you see that? Not more than 120, less or equals to 120. Then less or equals to plus 0.5. So back to the same thing lah, okay? Shouldn't be a problem. Okay, steps for normal to binomial. So the first step, you will define the original event. After you define the original event, you will define the binomial or the Poisson probability. Okay, then you will find the mean and standard deviation. Then you will change to normal. If it follows the rules, you change. When you do these changes, you will perform continuity correction. So continuity correction is the plus minus 0.5. Then you will change it to normal and you will find the answer using your calculator. Okay, I want you to follow these steps very closely. So let's look at this example now. Find the probability of obtaining between 4 and 15 hits. If they use the word exclusive, exclusive tells you include. Okay, inclusive tells you include, exclusive without, inclusive included. Okay, we had something like that when we did binomial. With 32 tosses of a fair coin. So 32 tosses, you know your n is supposed to be 32 lah. So using binomial distribution, alright, so let's look at the first way. If you use binomial distribution, you have all this to calculate. But I'll tell you, now your n is more than 20, your p is about 0.5, you have more than 10 probabilities to calculate, you can change it to normal. Because this question asks you to use binomial, you use binomial, all right? But if not, you can change it to normal. How to change to normal? Come. I don't know. Let me see. Okay, yeah. So now what's the first step? Define your event. Do you see that? Number of hits. It's just like how you did chapter 3. Same thing, okay? No different. Then you define your distribution. N is 32, P is 0.5. So now you look at it. 4 to 15, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you use your hands to calculate, you can see you have more than 9 to calculate, right? So you know you can change to normal. So when you change to normal, X with the asterisk, the B changed to N. What I want here is your mean and standard deviation. How to find mean? N times P. So N times P, 32 times 0.5 gives you 16. How to find your standard deviation? Square root of NPQ. 32 times P times Q, you will get this value. So you put it in 4 decimal places, square it and put it down. So 4 and 15 inclusive. So including 4 and 15 already. Okay, so now you need to do continuity correction. I want you to follow these steps. If not, you will make a lot of mistakes, okay? You will only do all this when you're changing from binomial to normal. Don't go and simply do correction all the time. So x is more or equals to 4, you minus 0.5. X is less or equals to 15, you plus 0.5. Then you change it to z-score, all right? And you put it in 2 decimal places, all right? Okay, then basically, what we are looking at here is already what you have been doing. Give you z-score, then you find the probability and calculate. So it's as simple as that. Okay, let's look at example 2. It is known that in a sack of mixed grass seeds, 35% are ryegrass. Use approximation to find the probability that in a sample of 400 seeds. When they tell you in a sample of 400 seeds, they are telling you this is a binomial distribution. In a random sample of, they are already giving you the piece. So this is binomial, because binomial always gives you two informations, N and P. Okay, so we will start off as I told you. Define the event first. Number of ryegrass seeds. Original distribution. N is 400. P is 0.35. Now you know, surely you must change, isn't it? You want to calculate 120 to 100. There's no way you can do it manually. So that's why I'm saying in your exam, it will be very, very obvious. So don't worry so much about memorizing the rules. Just know when your N is big, your P is small, you have so many to calculate, you have to change it. So you find your mean. How to find mean? N times P. 400 times 0.35, you'll get 140. Standard deviation, square root of NPQ, always put it in 4 decimal places. If you don't do that, you're going to make a lot of mistakes. Okay? So now, less than 120. So write it the way you see it. Less than 120 ryegrass seeds is Px less than 120. Then it will be lesser or equal to 119. Because originally this is binomial distribution, right? So if less than 120 seeds, I'm talking about how many seeds? Less or equal to 119. Because I'm going to use normal, can you see that? I'm going to do the continuity correction. Then I'll put an asterisk after my x. Okay? And since it's less or equal to, I add 0.5. Then you change it to z-score. This one is nothing for me to explain. We have just done it. You take 119.5 minus mean divided standard deviation. You will have your z-score. Make sure it's in 2 decimal places. Then use the method that you have just learned today to calculate your probability. Okay? Okay, now what about this? Between 120 and 150 ryegrass seeds inclusive. Inclusive tells you 120 and 150 is already included in whatever it is that you are calculating. All right, so you know you have to use normal distribution to calculate this. X star, you minus, because this part you minus, this part you add, you'll have 119.5 to 150.5. After that, same steps, change to z-score, find probability. More than 160 ryegrass seeds. So more than 160 ryegrass seeds tells me I want 161 and above, correct? So if I do continuity correction, I will minus 0.5 because it's more equal to. Then you change it to z-score. All right, are we good there? Okay, now weather balloons have an 80% chance of being recovered within 3 months of being released. 50 balloons are released around Geraldton in 1997. Estimate the probability that within a 3-month period, okay, less than 35. Now, many students get confused with this. Is this binomial or is this Poisson? It will be binomial. Because of the time period, they say, oh, it may be Poisson. It will be binomial. Why? Because the N is given to you already. Okay, and you have P, the chance of it being recovered. And the question is asking you how many are being recovered, isn't it? So original event number of balloons recovered. With a binomial distribution of N is 50 and your P is 0.8. All right, then you find your mean and standard deviation. All right, as usual. Then less than 35. If I'm talking about less than 35, weather balloons, that means I'm saying it's 34 and lesser, right? Therefore, you change it to x lesser or equals to 34. All right, then you do continuity correction. At least 42, more equals to 42. This has nothing to change already. It's already sorted for you. So more equals to, you minus 0.5. Then you do the necessary. You change it into z-score, find your probability. So that's all right, isn't it? Next one, Poisson distribution. So Poisson distribution, your mean will be the lambda here, 42. So when you change it into normal distribution, okay, your lambda will be your mean. How to find standard deviation? Square root of lambda. So if you square root 42, you will get this. Write it in 4 decimal places. Okay, same, everything that from down here onwards, the method remain the same. If x is less than 50, x should be less or equals to 49. So less or equals to 49, then you plus 0.5. Then you change to z-score. All methods remain the same. No problem. Okay. Then you have example 5. An online bookshop is a new internet site. In a 24-hour period, the site receives 600 hits on average. Assume that the number of hits per hour. So we're looking for per hour. So this is from Poisson distribution, chapter 3. I don't think it's a problem. Number of hits per 24 hours is 600. Number of hits per hour, it will be 25. If you cross multiply or however it is that you're finding it, that shouldn't be a problem. Okay, you just divide it, you can get the answer. So you know your lambda is more than 10, it's big, you're going to change it to normal. So your lambda is your mean. Okay, square root lambda 5 is your standard deviation. Less than 20, if I'm saying less than 20, it is less or equals to 19, right? Okay, then you have, less or equals to, you add 0.5, you change to z-score, same method, all right? Okay, all right, let's look at this. The mass of a coffee powder in a randomly selected jar sold by a certain supermarket may be taken to have a normal distribution with a mean of 400 to 3 grams and standard deviation of 3 grams. Okay, so this is a normal distribution question here. All right, I don't think this question is in your manual actually, but I'll just go through it here because it's a little bit different. So this is originally normal distribution, right? It's not any different, right? Originally normal distribution. Okay, so originally normal distribution, they tell you at least 400. So you change it to z-score. Make sure your z-score is in 2dp, all right? Okay, so you change 400. What do you get? 400. You divide with minus 403, correct or not? Then you divide with 3, you will get negative 1. So your z-score is basically less or, more equals to negative 1, correct or not? Then you just find your probability using your calculators. Okay, so for this part is a little different. This one I will teach you during another, I'll use another video to teach you. Okay, this is for normal distribution. Okay, so now let's look at exercise 4.2 question 1. Very repetitive actually, so it's the same thing. This is originally a binomial distribution. You write the original event, original distribution, change it to normal, then you see 15 or less, then plus minus, 20 or more you minus, so you just find, change it to z-score and find. All right, same goes to this. If 50 coins are tossed, what is the probability that you will get 23, 24, 25, 26 or 27 hits are obtained? Okay, use binomial to solve because although the conditions are met, the number of probabilities is less than 10. You must make sure all of the conditions are met. You have the n is more than 20, the p is less or equal to 0.5, but you must also have greater than 9 probabilities. That means 10 or more probabilities to calculate. Here only how many? So that's why you're doing manually. But of reason, we have been accepting both. Okay, so same goes to this. All right, more than 20 patients. So more than 20 tells you, this is where students always go wrong, you know, because they get confused with normal distribution. This is originally discrete. Originally discrete, if I say more than 20 is 21 and above. So you must always think, oh, this is normal distribution, you must answer it correctly. This is originally binomial and Poisson, I need to answer it this way. Understand? So more than 20 becomes 21 and above, then you do the continuity correction, change to z-score, find probability. Okay, this one you will use binomial to answer. Why? Because you have less than 10. You must make sure all rules are met. Okay, next one. A fair die is thrown 200 times using normal approximation. So your n is 200. What's the probability you get a 5? How do you do this? What's the probability you get a 5? 1 over 6, right? So you change it into 4 dp here. Why do I ask you to do that? Because you're going to change it into normal distribution. You're going to find n times p. So that's why it needs to be in 4 dp. When you transfer your values, it would be accurate. Understand? So you find your mean, you find your standard deviation, and you answer as per usual. Okay? All right, there shouldn't be a problem. Okay, same goes to this. You have your n and p, you change to normal distribution and you find it. All right. Question 6, same thing. It's originally binomial, then you change it to normal and you do as per usual. If there's anything that you don't get, just ask me, okay? All right, and this one, this question has always been a question, students always ask actually. So insurance company in Australia use tables which give probability of death within 1, 5 and 10 years for a person of any age. For an example, the probability that a man age 71 dies within a year, meaning within 1 year, is 0.01. An insurance company has 5251 policies for men of this age. That tells you the N is 5251, and the probability that the company has to pay it out, a paid out policy, will be 0.01, because if they die, the company has to pay out. So what's the probability of them dying? The mortality rate is 0.01. Therefore, your probability here must be 0.01. Do you understand? That is where you get these two values from. All the other information is totally not relevant. Within 1 year, 5 years, 10 years, nothing to do with you. What you want is the N and P, and you got that, that's it. All right, then whatever that you do after that will remain. So you don't need to draw the table like me. You don't need to draw this table. You don't need to write all these things. But what I just want from you is follow the steps, because students who skip steps always make mistakes. Okay, so I will stop right here for this class. If there's any questions, please make sure you reach out to me, because this is basically quite an important topic for your exams.